Okay, design. Jimena.
Yeah.
So for people who don't come from the world of chip design, how would you explain why design, even without owning fabs, can be such a powerful way to innovate and create value? So we're back to the design question that animated so much of the discussion yesterday, and let's get your perspective on that.
I think, first of all, design, by definition, solves the fundamental problem that it's addressing. So you phrase the problem, and the design should be solving it by definition. So it's at the core of where the value is created. Secondly, and it's another topic, it's quite easy to innovate in terms of design. Just give you room for escalation until it comes into productization. So it's very straightforward transfer of know-how. And finally, and at least in the industry in semiconductor, design relies at the core of many key ecosystem, and you can think of NVIDIA, you can think of ARM, as you mentioned, Synapses, etc. So it's very clear that it plays a pivotal role for the industry to create value and to create innovation.
So let me turn to you, Jose, and talk a little bit about, from the industrial company perspective, about how you evaluate risk and how you decide to adopt a technology. Oops. Okay. We'll have some slides coming up, but maybe you can take that one on. So yeah, speaking from a
so the introduction of a new technology.
Yeah. How do you evaluate it? You think about risk. What makes it worth your taking that risk?
Yeah. So the risk to introducing a new technology into a fab environment, it has to compensate. The value has to really overcompensate the risks. So there's no such a thing as how to trust in order to introduce without a risk. There is always a risk to introduce any technology into a fab environment. So there is multiple activities that the value chain, the ecosystem, does to decrease the risk. I can speak from my perspective on my role as being working ASML, but also being on the side of Samsung. There is a strong collaboration between the equipment manufacturer and the chip manufacturer, where they look into the roadmap well ahead. So every single step, we've been talking these days how difficult it is to advance the roadmaps. I've been living that firsthand on a daily basis with our customers. So every single step means driving critical specs like imaging. In my case, I was working in the DPV business unit of ASML, which is how to improve overlay at the most advanced nodes. To give you an idea, I was product manager of a tool who wanted to improve the overlay, which is what's the position of a layer, the bottom layer with the upper layer. So chips you build basically stacking layers over time. So to reduce from 1.5 to 1.3 nanometers. So there is a full program of hundreds of millions in order to improve the overlay 0.2 nanometers. As a reference, the size of a silicon atom is 0.1 nanometers, right? So we're already working at an atomic level at a massive speed. So how do you reduce the risk on that environment? So there is first every single change that a new tool brings versus the previous tool is analyzed extremely deeply, what it changed versus the previous design. What does it change on the tool, impact on the software, impact on the customer environment. So this risk assessment is not done independently by the company. We are bringing now what use case will be used for this tool, a specific environment on the customer fab. So at the end, there is a continuous work going through years of collaboration to the risk that introduction of a new tool into the customer fab environment.
So yeah, so this whole evaluation of risk is a very complicated process all the way through.
It's all about risk reward and anything that comes into the fab. So we will discuss how to introduce new products into the semiconductor industry. The value has completely to overcome the risk that it brings. And how to demonstrate, I mean, first, there is no trust in this industry. It's all about proof data, right? So you need to demonstrate with data how does your solution in a certified or tested proper environment will really help and demonstrate the value that it brings.
Right. I'm going to come back to you, and I know you had some slides you wanted to show. So
I want to use this one.
go ahead if you wanted to bring it up.
It's okay. Come with the question.
Well, I wanted to move on to talk to you about IP, intellectual property,
Yeah.
and how that is a big question for you in the world you're in.
So I think, first of all, I would like to set the ground. What is IP for the industry? What is IP for the academia? This is one of our patents, okay? Typically, the worth of a patent is 0. Because for what we call IP, intellectual property, in terms of industry, it's not, first of all, it doesn't refer also to patents. It can be something that is already existent, but you have more ability to productize. Secondly, the most important thing is it needs to be repeatable. Industry cannot afford failure or inconsistent failure. Thirdly, you need to come with something that is useful, that solves a problem. It doesn't need to come in a white paper being the smaller, the bigger, the faster. It needs to solve an industry problem. Additionally, it needs to be able to work in the industrial environment, and that means being compatible with the tools, the workflows that the industry is usually using. In the case of semiconductor, we all know the usual players, synapses, cadence, etc. But it also needs to be available with the volume, what the customers are working with. That means, and coming back to Pepe's comment, there's no trust in the industry. So since theory and reality come in different paths, you need to make sure that it's being measured in an actual scalable process. So putting all this together, then IP is amazing for the industry because it shortens time, development cycle, and coming back to the talent conversation, required know-how. You can build on blocks, black boxes that you know inputs, outputs, and behavioral models and are trustable, then a number of applications can be built upon without the need of starting from scratch, spending or long, what we call IP implementation cycles, and bringing application and industries and making possible the monetization of the research and the innovation.
I want to come back to you again, Jose, and talk about standards.
Mm-hmm.
You're working with incredibly complex technologies at ASML. What role do standards and interoperability play in adoption by customers?
Standards are a must. So without the standards, it's not possible to have a fab.
Right.
Philip was commenting before that a semiconductor in advanced nodes, it goes through 400, 500 different processes. A fab is like an organism with hundreds of different tools where the wafers, they go from one place to the other. So you need to have a standard where everything is able to talk together. Also, the whole value chain, so all those different tools into the fab, they need to, so the wafer, for example, is always the same size. The fabs where the wafers move along the fab, all those things, the software, the interaction, the interfaces between the different tools, everything is already standardized. And of course, the standards can be changed, but changing a standard is tremendously difficult. Let me give you a couple of examples. So for the last couple of years, in order to improve performance of one of our tools, it would benefit to tighten up the specs of a...
I didn't catch that. It would benefit to
tighten up
okay.
the specs of a wafer, right? The wafer has a flatness spec, thickness spec, edge shape specs, all at the, I would say, micrometer precision. But in order to improve those specs, it will eventually result in better performance for the customer, better yield, lower cost. But even something that you must say straightforward, let's do it, it's very easy to do. It will take a proven from the semi. It will take negotiations with the wafer manufacturers. It will eventually change the processes of the chip designers. So something that you might seem straightforward, it requires long approbation time. So it didn't happen during my period. This is still work in progress, my period in ASML. And a second example, we talk about 450 millimeters wafer. Yesterday was a comment from Ajit as well. So it was part of the department in Samsung who managed two big agreements on the industry. One was the EUV, when the EUV, it was sort of a high-stake project with a lot of high cost. So basically, ASML requested to the leaders in the industry, Samsung, TSMC, Micron, Intel, to provide some funds in order to develop the technology. In that case, changing the standards, because changing the type of light, it would benefit ASML, it would benefit the semiconductor manufacturers, and the changes were relatively manageable into relatively scope. So that project came to fruition. It became today leading edge technology. But the second one, the 450 millimeters, it was a failure. I mean, it didn't happen. While it will bring a lot of benefits because it will reduce the cost of semiconductor manufacturing, it was a project that it will affect the whole equipment manufacturer, the whole ecosystem. We have to change the standards. So the cost of developing and changing those standards was way higher than the benefit that will bring. So it was a standard that makes total sense, but the impact to the total ecosystem was so high that even the gain didn't make sense at the moment. So who knows, maybe 5, 10 years from now, this might
these are the
be the
things
case
you're
happening.
watching, and you could possibly do this in the future.
Is how important the standards are, but also how difficult they are to change.
Yeah, so that's a key thing. Let's talk a little bit about specifics in Europe, given your experience in photonics and design, and if there are things that could be improved in the European ecosystem that could help move from design to product more quickly.
I think absolutely. I think it's very clear that we are very powerful in terms of creating new IP, in terms of academia. There are many research about it. Europe is filling a lot of patents. However, we don't monetize them. So we don't have the ability to turn IP into actual some products, or the ability that JASM is something we are not doing. And we see a number of initiatives related to, sometimes I'm going to be a bit controversial, to pilot lines, to collaboration project. But what we see that is in most of these situations, the actual industry, customers, the key players of the industry, which are a limited number in this world, are not usually present. That means European companies, academia, developing IP, developing design, cannot learn of the challenge of actually scaling. And absolutely there are technological challenges for what research center or innovation transmission center can help. But there are a number of operational challenges that they cannot provide the answer, because that's not where the background comes from. So I think if the European Union could manage to bring earlier both customers, both key stakeholders, was mentioned before the involvement with TSMC, key foundries, so key EDA companies who are not European any longer, by the way, that will really helps to bring all this design into actual scalable production, being able to monetize, to get something out of it. Mechanism might be only within the European Union? I doubt so. I think we are in a situation, and it's been covered this morning, where we need to learn again how it's like to work in this industry, because we lost that know-how. So I would encourage to bring into this kind of process of escalation external players, I mean foreign players. That's the one thing. Second thing is building IP, building ecosystem is extremely time and costful. And usually the way to transfer technology is through a spin-off, and we are a good example out of it. So it takes a lot of time to build IP into a product. I mean an IP product, an IP that can be licensed or used by another company, because you need to qualify, because you need to be available at different EDAs, you need to be available at different foundries. And along that journey, you're going to need cash to pay these amazing engineers. We are very lucky, so we have a lot of support for our ecosystem, but still you're going to pay a number of things. So I think nurturing a model where private and public capital can jointly foster this long-term IP and design companies is essential to their success. Otherwise, this is not going to happen. And that's a reality. I think also we have an opportunity there as Europe. And I don't know if it's on the slide, but one of the slides is basically, in photonics, there are not one sitting, but us and a couple of other companies, 3 companies, as IP providers in the world. You have the customers,
I'm not
same
sure
customers as
we're
in
seeing your
semicon.
slides.
You have EDA
Right.
tools, same tools everyone is using in electronics. You have material equipment, same players. You have foundries, same players. But IP is a green field. We have the know-how, we have the people, we need the money and the time to execute. And I would encourage a lot to consider seriously how we occupy that empty space.
So Jimena, the slide wasn't up, and I don't know if you want to just talk about it a little bit more while I know you were referring to it.
Yeah, but it's okay. I mean, it's quite clear. We all know all the players. It's a very simplified version, but it's not simplified for IP, and that's shocking. A lot of people are doing design, amazing design. We have BLC here. But few people are taking this road because it's a long investment road. Still, we know it pays off.
So a lot of the things we seem to be talking about are lack of alignment or trying to help one field work with another. And I want to tackle that question in a little bit of a different way with you, Jose, and that's, what advice would you give a young company that wants to enter a global supply chain or work with the big players? How do you get from this ambitious young company?
So I've been having conversations out there during these days with some people on the forum. I think you need to understand the challenges that the big companies have, right? So what's the value that you drive?
Right.
So how is that value measured? What's the key? For example, in semiconductor manufacturing, we call it the main triangle, the value triangle, which is historically it's about imaging, productivity, and overlay, right? So if you were, I mean, this is a bit from the lithography perspective, but this is key areas where, for example, from the lithography, how do you look into your customer? What value do you derive? And from there, how do we improve into those different value drivers? So if you are a new company, what value driver do you bring? How do you help? Those big companies, they have extreme amount of pressure to deliver on the R&D phase, on the ramp phase, on the mass manufacturing phase. So you can decide where to place your product. So I've been also following some Spanish companies, some of them now positioning themselves into the high value added into the chip manufacturing, more on the metrology side. But first you need to demonstrate the value. There is a pain point, which is how much time does it take for a manufacturing company to be able to measure the topography of the wafer, right? This company is able to do extremely fast, right? So if you are able to bring such a value, demonstrate into the lab. What we talked before, what is the proof book? So you're improving productivity, you're giving a lot of value into analyzing what's happening on that wafer, demonstrate the technology, what kind of tests do you do, how do you demonstrate that your product actually works, and then if you want to go to play the big league, how do you industrialize that product? How are you able to work? I didn't discuss before, but there is two concepts critical in, I would say, mass manufacturing, which is precision and accuracy. Accuracy means how close you are around the target point, right? But precision. But precision is how repeatable is your process, your solution. So in this case, repeatability is key, because maybe you are not aiming to the right spot, but you can always calibrate.
You hit it once in a while. Right.
Or you can always calibrate the tool in order to, but for example, are you able to be reliable to have that precision that the mass manufacturing needs, so you can move from a lab tool or a lab solution into a mass manufacturing solution. So understand the value, demonstrate the value, and be able to integrate into a mass manufacturing environment, if that's the goal.
Great.